Hello and welcome to OpenLogic. In this video, we're going to look at a UVM object. And first, let's do a quick recap. In a test bench, there would be a design. It is a hard component, which means that it cannot be instantiated dynamically at any point of time. And then there's test and components which are used to validate the design. Now, these are soft components, but they are instantiated at time 0 and they stick around until the end of simulation. From time to time, the test will generate transactions which will be translated into signal activities by the components. In contrast, transactions only exist for a brief moment of time. If we look into the UVM class diagram, generally we use these red classes to model the test and components, and we use these blue classes to model the transactions. In a simple manner, the blue classes represent data and the red classes manipulate data. But since both of them deal with data, some of the functionality are being put into the UVM object, which is the focus of this video. This is a class. It contains a bit and an int, and they represent data. To use the class in a test bench, we need to declare some handles, and then we need to instantiate them. There are several things that we want to do with the data. For example, we want to display them, copy them, and compare them. Now, if you have tendency to write code in this manner, you should always consider to write a function inside the class. Else, this would be a very difficult code to maintain. For example, if we add a new string s into the class, then we need to update all this code to include that string as well. And the same goes to if we add a new class handle here, we will need to repeat all this code for that particular handle. As I was saying, it is actually a good idea to have functions or tasks in the class to help to manage the data. And this is a doPrint function which prints the value of a b and I in the class. And this is a doCopy function where given a target, it copies the value of a b and I from the target to this class object. And this is a doCompare function where given a target, it compares the values of b and I between the target and this class object. Now we can replace this code here with functions called from the class. We can call doPrint to print the value of b and I in the class object. We can call doCopy to copy values of b and I from C1 to C0. And we can call doCompare to compare the value between Z0 and C1. It's obvious that with the functions, this code is more maintainable and much easier to understand. Looking at the case where we add a new handle C2, it is comparatively easy to display the value of the members, to copy them, and to compare them. And the other case where we add a new member string s, this code would not be affected at all. All we need to do is to update these functions to include a new member. Alright, now let's see how to do this with the UVM. First, we need to extend this class to UVM object, and then we need to add in this UVM object utils macro and a constructor. And we need to use this create function instead of the original new constructor. And do check out this UVM factory video if you are not familiar with this. As a UVM object extension, it has all the print, copy, and compare function, so we don't need to redefine them. However, these functions are unaware of these new members variables that we add into the class C. And therefore, generally speaking, we need to overload these functions to include the new member variables. And this is an example of overloading the doCopy function. As a function from the base class UVM object, we cannot change its definition. For example, this doCopy function requires an argument of UVM object. From the outside, when we call the copy function with an argument of C1, which is a C object, it would appear as a UVM object inside the function. As a UVM object, it is unaware of the bit b and int I, and therefore we need to do a typecasting. By doing this, we are converting the UVM object RHS back to a C object. And only after that, we can perform the copy operation. The point of this is, however, as you can see, it is actually quite troublesome to add a new member variables in the class and then having to update all the functions. And therefore, UVM has a somewhat better mechanism to achieve this. And this UVM object util macros, it is actually a simpler version of these two macros. And if we are using this version of the macro, we can add new defines in between to indicate how these member variables can be utilized by the functions. And this example says that I want the member variables b and I to be included in all the functions. For example, if we call c0.print, this would be the message, and if we call c1.print, this would be the message. As you can see, the UVM object has a well-defined printing format. The member variables b and I are displayed in the message because we use these macros here. And this is the C0 object, and this is the type of the object, which is a class C, and this one is an ID of the object. You can think of this as the 127th UVM object that is being created. B and I are the member variables. Integral means that they are numbers, and these are the size of the variables, and these are the values. In a similar manner, if we call the copy function, it will copy the two variables b and I, and if we call the compare function, it will compare the two variables as well. All of this is made convenient because of these two macros that we put here. And before I forget, do remember to import a UVM package in order to use this UVM object. Now let's go deeper into this mechanism. And there are two parts, the macros and the flag. First, the macro. And this is UVM field int. The int here means integral, it doesn't mean integer. So basically, if you have any number types, you should be using this UVM field int. If we have a string variable, then we should be using UVM field string. And if we have an enum, then we should be using UVM field enum. And if we have a class handle, then we should be using UVM field object. Unfortunately, this doesn't end here. If we have a static array or a fixed size array, we should be using this UVM field as array int. In a similar manner, this is the macro for a dynamic array, this is the macro for a queue, and this is the macro for an associative array. If you pay attention, these are arrays of numbers. If you have an array of string or an array of class, then we should be using their respective macros. And now the second part, the flag. These are some of the flag values. UVM all on means that I want these member variables to be included in all the functions. UVM no copy means that I want these member variables to be excluded from the copy function. The UVM no compare means to exclude it from the compare function, and the UVM no print means to exclude it from the print function. And the way to use these flags is to all them together. For example, if I apply UVM no copy here, it means that this member variables is included in all the functions except for copy function. If we call the print and compare function, they would operate on both the member variables b and I. But if we call the copy function, it would only operate on I, because b is excluded from the copy function by this flag. And there are also some other flags which are used for printing format. For example, UVM bin here means to print the number in a binary format. If we apply this UVM tag on these member variables I, then the printed messages would print I as a decimal number. Now, one more thing before we go. If you have noticed, I have used different naming on the function. For example, I've used copy and I've used doCopy. And the reason for that is because in UVM object, there are these two functions, copy and doCopy, print and doPrint, compare and doCompare. The one without do underscore is a higher level one and should be used by a class object. The one with the do underscore is a lower level one, and in my opinion, they should not be called directly. Basically, copy will call doCopy, print will call doPrint, and compare will call doCompare. The thing to note here is that copy, print, and compare function are non-virtual functions, which means that they cannot be overloaded by an extension class. Practically, it means that these functions are so well written that no one should attempt to override them. On the other hand, doCopy, doPrint, and doCompare are virtual functions, and these are the ones that we should overload in case we want to do something extra. By default, the doPrint, doCopy, and doCompare function does nothing in the original definition inside the UVM object class. Alright, that's it for this time around. Thanks for watching. Do help to support by clicking like, share, and subscribe.